2.6 is trig limits, part 1. I've actually decided to split this into 2 parts because I feel like it's kind of a lot. Even this video will be a little longer than normal because I want to do several problems. Otherwise, I think you'll have a hard time figuring out all the different things that can happen. So we need to go back and remember sine and cosine just a little bit. Every time our limits are trying to figure out as x approaches 0. So as we're coming to the middle of our graph here. If you remember a sine graph, it goes through the origin, so sine of 0 is 0. And cosine had it to where it started up here at high, that high, middle, low, middle, high cycle. So cosine at 0 is up at 1. So you could think of the graph, or think about our unit circle when we have like cosine of 0. So that would be at 0 degrees. We're not even making a triangle. It's just the ordered pair. We went right 1, up or down 0. Cosine is always the x value of the ordered pair, whereas y is always the y value of the ordered pair. Because remember, normally we had triangles here, and cosine, ka, is the adjacent leg, which is this horizontal distance from this angle here, and then sine is so, which is opposite side the height. Well, this point didn't go any. But anyways, so somehow remember cosine and sine of 0. So we've got our limit here. The best thing we could do is just direct substitution. And I'm telling you up front, you can do that. But in your problems, you won't know if you can or not, so we have to try it. So let's plug in -4 sine of 0. I don't put parentheses around it like they do. Over 7 cosine of 0. Well, sine of 0, we said is 0. And then cosine of 0, we said is 1. Well, -4 times 0 is 0, divided by 7 is 0. So that worked because we got 0 on top. That's fine. Number 2, let's try it. We got -10 plus 4 cosine of 0, and again, because that's what the limit wants us to find, over 3 times 0 minus 1. Cosine of 0 is 1. So it's -10 plus 4 over -1, which would be -6 divided by -1 or 6. Done. But if we look at number 3 and we were to try that, we would do 7 times sine of 0, which is 0, over 8 times 0 squared, which is also 0. This is indeterminate form. That means it doesn't work. We don't know if it exists or not until we do some work to it. And the work that we need to do to it is to use this identity. This is something you just need to memorize, that if I have the limit as x goes to 0 of sine of x over x, that will always equal 1. Okay? The other thing you need to know is that I could reciprocate that, so flip that fraction, and that's also still 1 because the reciprocal 1 is 1. I also included the graph of sine of x over x, and you can see as x is coming to 0 that it's up at 1. So just to kind of prove why that is. But in this problem, what I want to do is rewrite it somehow. So I'm going to take out the leading coefficients here and just get them out of my way and have the 7/8. That's a property of limits I can do. Times the limit as x goes to 0 of sine of x over x squared. Again, I don't like their parentheses around the x, so I just take it off. Okay, I'm so close to having it match this. The only thing that's wrong is having the x be squared. So then what I'm going to do is have 7/8 times the limit as x goes to 0. I'm going to have sine of x over x so that I can get this that I wanted. And then to get another x, I would have to have the limit as x goes to 0 of 1 over x. And here's the reason why. Ignore the limit part. If I were to have these fractions that I multiplied, sine of x times 1 is sine of x times x is x squared. You can split up fractions that are all multiplied just by splitting them however you want. Okay? So this, now I know is really 1. So I have 7/8 times 1 times, think about this though. If I had 1 over and I plug in 0, that does not exist. So if I'm trying to multiply something times something times something that does not exist, this whole thing does not exist. So that one was kind of a weird one to start out, but if that would have been a number, we would have just multiplied and it would have been good. All right, number 4. Again, we're close. I'm going to take out that negative 10 so that I have negative 10 times my limit as x approaches 0 of sine squared of x over x. I don't want sine squared, I want just sine. So I'm going to split that up again so that I have a sine of x over x times the limit of, I needed another sine of x, so that these got multiplied to make the sine squared, and just put it over 1 or just leave it. Now I know that this is 1, so I've got negative 10 times 1 times, as x goes to 0, what's sine of 0? We said that that is 0. So we've got negative 10 times 1 times 0, actually just makes 0. But I was able to break it apart to where I could evaluate each limit. All right, last one of these. This looks totally different than what I'm trying to get, but I do see that I can factor something out. So this is a 28 sine squared of x. That's a sine times a sine minus 20 sine of x. 28 and 20 can have a 4 factored out. So let's go and do that. I'm not going to write the limit yet. Take out the 4. I can also take out a sine from each term. And then that would be 4 times 7 makes 28 times sine of x minus, I just need a 5. Because negative 5 times 4 makes 20 sine of x over 4x. Okay. Then I'm going to take out my, let's see, let's actually separate this. No, I'm going to take out my 4 divided by 4 to cancel. So see the sine of x over x? I can just split this here because there's multiplication. So I'm going to have a limit as x goes to 0 of sine of x over x times my limit as x goes to 0 of 7 sine x minus 5. Okay. This is my identity, which equals 1. So I have 1 times, then here I'm just going to direct substitute. So plug in 0. Sine of 0 is 0. 7 times 0 minus 5 is negative 5. 1 times negative 5 is negative 5. All right, and then the last 3 are dealing with another type of identity. It's this 1 minus cosine of x over x. That will equal 0 when the limit is going to 0. Here's a graph of it. You can see that as x is coming to 0, we're right here at 0. But if I were to reciprocate that, flip it, it does not exist, because the reciprocal of something that's 0 is does not exist because it puts 0 on the denominator. So both of those can be used. Okay, so see how I've got 9s here? I can actually factor that out. So I'll take out a 9. That'll be a 1 minus cosine of x, which is exactly what I'm wanting, over 2x. Okay, then I can take out my 9 halves in front of the limit and it gets multiplied. So 9 halves times 1 minus cosine of x over x. Perfect. So this is really 0. 9 halves times 0 would be 0. Number 7. Nothing I can factor out. I see that it's going to match this identity because I see cosine of x minus 1 on the bottom. The only thing really I could do is take out this negative 3, put it in front. And so then I would have x over cosine x minus 1. Well, what does that limit equal? That's a does not exist. So a negative 3 times something that we have no idea what it is, it doesn't exist, is overall does not exist. And then the last one, we're going back to this identity. See how there's 3 terms here, but I can't factor anything out? What I'm going to want to do is first probably rewrite this. Let's rearrange the orders so that I have 1 minus cosine of x, like I want here, plus 5x all over 10x. Okay, then I'm going to split this up into my 1 minus cosine of x over 10x. And see this plus here? Then I'm going to put plus, I'll leave some space here because this is really a limit, plus the 5x over 10x. And you might think, well, how did you know to do that? Well, when I don't have multiplication, where I'm trying to, like this one, I've got multiplication of 9 and then this identity here, you split up with multiplication. Well, when I have addition subtraction in a numerator, I can split it up, but I have to keep the common denominator. Because if I were to put these two fractions back together with addition, I would have my common denominator of 10x, 1 minus cosine of x plus 5x. It was exactly what it originally was. So that's how I kind of know, hey, that works. And then on this one, I would take out the 10, which is in the denominator. So that's really 1/10 times the limit as x goes to 0 of 1 minus cosine of x over x plus your x's can cancel. And then you have 5/10, which is a half. You could take that out in front and not have any limit left. Or what this means is that your function is just a horizontal line like this. And so any limit here, it just equals 1/2. So let's see if we can figure out all together. This is 1/10 times this limit is 0. So that makes 0 plus this is just a half. And so we get overall answer of 1/2.